students, welcome to Sunil's tutorial. I'm Sunil Milwani and today we'll be doing this chapter called as surface tension. We are going to do numericals of surface tension. Please take down a sum. Water rises to a height of 5 centimeters. Water rises to a height of 5 centimeters. Water rises to a height of 5 centimeters in the capillary tube. Water rises to a height of 5 centimeters in a capillary tube. In the same capillary tube, mercury is depressed by 1.54 centimeters. In the same tube, mercury is depressed by 1.54 centimeters. Compare the surface tension of water to mercury. Compare the surface tension of water to mercury if the density of water is 1000 kgs per meter cube. The density of mercury is 13,600 kgs per meter cube. The angle of contact of water is 0 degrees. And the angle of contact of mercury is 130 degrees. Now, we know that the surface tension is equal to RH rho g upon cos theta to cos theta. Right? So in that case, for water, surface tension of water will be height of water will be equal to radius of the capillary tube, height of water, density of water, G as it is, upon 2 cos theta for water. This is angle of contact, so this should be theta water and this is theta mercury. Okay, and surface tension for mercury is going to be R H mercury, density mercury, G upon 2 cos theta mercury. And if I divide the two equations, I'll get surface tension of water to surface tension of mercury is going to be nothing but height of water upon height of mercury into density of water upon density of mercury into angle of contact of mercury, cos of angle of contact of mercury to cos of angle of contact of water. Right? The angle of contact of water is given to you as 0 degree, angle of contact of mercury is given to you as 130 degree. All the values are given to you, all you need to do is just substitute. The answer for this sum should be equal to 1 is to 6.515. Next, take on next one please. Compare the amount of work done. Compare the amount of work done in blowing 2 soap bubbles. Compare the amount of work done in blowing 2 soap bubbles. Compare the amount of work done in blowing 2 soap bubbles of radii in the ratio of 4:5. Now work done is tension into change in area soap bubble. For a soap bubble, the soap bubble is in the form of a sphere and it has two free spaces, two free surfaces. Therefore, this is going to be 8 pi r square. Hence, I can say that work done is directly proportional to r square. Therefore, W1 upon W2 is equal to R1 upon R2. Should be able to get the answer now. R1 square upon R2 square, sorry, because it's square of the radius. This is square of the radius, so it will be R1 square upon R2 square. W1 upon W2 is equal to R1 square upon R2 square. Let's take our next sum, please. The answer for this sum should be 16:25. Next, take our next sum. A needle 5 centimeters long. A needle 5 centimeters long can just rest on the surface of the water. Can just rest on the surface of the water. Can just rest on the surface of the water without wetting. Find the weight of the needle. Find the weight of the needle if the surface tension of water is 0.07 newtons per meter. F is equal to TL. T is given to you, L is given to you. Now, since the needle is resting on the surface of the water, since the needle rests on the surface of the water, therefore its weight is going to be balanced by the force of surface tension. Therefore, its weight will be balanced by the force of surface tension. So that means, therefore, I can say that weight of the needle therefore will be surface tension, force of surface tension. So weight of the needle will be equal to F. F we have already found out is TL. So in this case, the weight of the needle will be nothing but TL, right? The answer for the sum should be 3.5 into 10 raised to minus 3 newtons. Next, take our next sum, please. A mercury drop. A mercury drop. A mercury drop of diameter 10 millimeters, of diameter 10 millimeters, falls and breaks into million droplets. Falls and breaks into million droplets of equal size. Find the height from which the drop falls. Find the height from which the drop falls. Find the height from which the drop falls if the surface tension of mercury is 0.5 newtons per meter. Density of mercury is 13,600 kgs per meter cube and acceleration due to gravity is 9.8 meters per second square. Now let us assume that let R be the radius of the droplet. If r is the radius of droplet, that means I can say that the volume of drop should be equal to the volume of droplet. Right? Volume of drop is 4 by 3 pi r cube. Volume of droplet 4 by 3 pi r cube. Now it breaks into million droplets, that's into 10 raised to 6. So in that case 4 by 3 pi gets cancelled. So I can therefore say that taking cube root r is 10 square into r. If I take cube root, so I will get r is equal to 100r. Right? Once I have this, next let's find out the increase in surface area. Increase in surface area, dA, is going to be nothing but surface area of the droplet, million droplets minus the surface area of the drop. So this is going to be nothing but surface area of droplet minus surface area of drop. Surface area 4 pi r square. Since there are million drops, into 10 raised to 6 minus surface area of drop 4 pi r square. Right? Now in this case r is equal to 100r. So I can therefore say that 10 raised to 6 4 pi r square minus 4 pi, r can be written as 100r the whole square. So in which case you will get this as 4 pi common, 10 raised to 6 r square minus, this is going to be 10 raised to 4 r square, because 100 square will give you 10 raised to 4. So this is going to be 4 pi 10 raised to 4 common, 100 r square minus r square. I could take r square also common, so you will have 4 pi into 10 raised to 4 r square common. That will leave you with 100 minus 1. So in that case you will get this as 4 pi into 10 raised to 4 r square into 99. That is going to be my increase in surface area. Once I know the increase in surface area, then I can find out the work done. The work done is the same as the force. So work done is going to be nothing but surface tension into increase in area. Work done is surface tension into increase in surface area. Surface tension is given to you, increase in area you just found out. So you should be able to get this answer. Now let us assume that the potential energy of the big drop at height h, let potential energy of drop at height h is used to perform work. In which case I can therefore say that mass is density into volume, right? So in that case I can say that mass is density. The volume of the drop will be 4 by 3 pi r cube, right? Now potential energy we know is nothing but mgh. So potential energy m we know, g we know. Potential energy we've said that the potential energy of the drop is used to perform work. That means I can therefore say that W is equal to mgh. That means I can say that therefore W is equal to mgh. W can be written as T into dA is equal to mgh. M we know, so you will get T into dA. M is nothing but rho 4 by 3 pi r cube h gh, right? Therefore you will get the height from where the mercury drop falls is T into dA upon rho 4 by 3 pi r cube g, right? You have all the values: tension, change in area, You also have density G and R. You have all the values, you should be able to substitute and get this answer. The answer for this sum should be the height from where the mercury drop falls is 0.2228 meters. Answer 0.2228 meters. Next, take down next one please. A vertical U tube. A vertical U tube. A vertical U tube consists of liquid in one limb of diameter 2.4 millimeter and other limb of diameter 0.8 millimeter. Other limb of diameter 0.8 millimeter. The surface tension and the density of the liquids. The surface tension and the density of the liquids is 0.05 Newton per meter and 900 kg per meter cube. Find the difference in the liquid level. Find the difference in the liquid level assuming the angle of contact to be 0 degree. Find the difference in the liquid level assuming the angle of contact to be 0 degree. Now, we know that surface tension is equal to RH rho g upon 2 cos theta. Therefore, I can say that H is equal to 2t cos theta upon R rho g. That will be the height. Now, since theta is equal to 0 degree, cos of 0 is 1. Therefore, I can say H is equal to 2t upon R rho g. Now, in a U tube, we know that the liquid in the two limbs balance each other, right? So I can say that, therefore, you can say that H1 will be nothing but 2t R1 rho g and H2 will be equal to 2t R2 rho g. Now they've asked you to find out the difference in the liquid levels, right? So I can therefore say that the difference in liquid levels is going to be H2 minus H1. This is nothing but 2t R2 rho g minus 2t R1 rho g, right? Out of which I could take 2t rho g common. You could take 2t upon rho g common. So this will be 1 upon R2 minus 1 upon R1, right? Substitute, you have all the values, you can get your answer. The answer for this sum should be 1.89 centimeters. Next, take on next sum please. A capillary tube of internal diameter, 2 millimeters, an external diameter of 8 millimeters, an external diameter of 8 millimeters is suspended vertically from one arm of a balance, and its weight is determined. And its weight is determined. If the lower end of the tube is then kept dipping in a liquid surface, if the lower end of the tube is then kept dipping in a liquid surface of tension 53.8 into 10 raised to minus 3 newtons per meter, and the angle of contact is 0 degrees. Find the change in the apparent weight of the tube. Find the change in the apparent weight of the tube due to surface tension. Find the change in the apparent weight of the tube due to surface tension. Right? Now, what if I'm going to dip this in? This is the lower end of the tube. I'm going to dip this in water. If I'm going to dip this in water, what is going to be the length of the tube that is going to be in contact with the water? The inner length and the outer length. The inner circumference and the outer circumference, these are going to be the two lengths that are going to be in contact with the water. Right? Now, the inner circumference is going to be 2 pi r I the whole square. The outer circumference, sorry, this is area. This is going to be 2 pi r I circumference plus 2 pi r e, the inner radius, and where r I is the inner radius and r e is the external radius. So that will be the total length that will be in contact with the liquid surface. Once I know the total length in contact with the liquid surface, then I can find out F. F is equal to TL. Tension is given to me, L is given to me. L we just found out. So you will come to know what will be the force that is going to be exerted. Once I know the force that is exerted, we have said that this force partially balances the weight of the tube. I can say that the force partially balances the weight of the tube. Now, since this force partially balances the weight of the tube, the change in the apparent weight of the tube is going to be this force. Change in apparent weight of the tube is going to be equal to F. So that will tell you how much is going to be the change in the apparent weight of the tube. Right? Whatever is your value of F, that will be the change in the apparent weight of the tube. The answer for this sum should be equal to 1.689 into 10 raised to minus 3 newtons. Next, take down next sum please. A raindrop of diameter 6 millimeters, a raindrop of diameter 6 millimeter falls on the ground. Calculate the pressure inside the drop. Calculate the pressure inside the drop. Calculate the pressure inside the drop. If the atmospheric pressure is 1.013 into 10 raised to 5 newtons per meter square, and the surface tension of water is 0.072 newtons per meter. Now, we know the atmospheric pressure, we also know the radius of the drop. Hence, I can say that the pressure inside the drop if this is my drop of water, guys, now the pressure inside the drop is going to be my external pressure, that is my atmospheric pressure, plus the pressure due to the liquid that is going to be there inside, that's water that is there inside, right? So the total pressure that is going to be exerted, the pressure inside the drop Pi is going to be external pressure plus 2T by R, the force is nothing but 2T by R, right? So in which case you will have, substitute the value, you should get the answer for this, right? Do we get this in here? Next, the answer for the sum should be 1.01348 into 10 raised to 5 newtons per meter square. Next, take down next sum please. A ring is cut from platinum tube. A ring is cut from platinum tube of 8.5 centimeter internal diameter, 8.5 centimeter internal diameter and 8.7 centimeter external diameter. And 8.7 centimeters external diameter, and is supported horizontally from a balance so that it comes in contact with the water in the glass vessel. So that it comes in contact with the water in the glass vessel. If the extra weight of 3.97 G 3.97 grams is required to pull it away from the water. 3.97 grams is required to pull it away from the water. Calculate the surface tension of the water. Now I can say that the downward force exerted by the tube will be nothing but F, which is nothing but TL. TL. L is going to be nothing but the length of the tube that is going to be in contact with the water. Since the tube is made up of internal and external diameter, the internal circumference and the external circumference is going to be in contact with the water. So in that case, you will have 2 pi Ri plus 2 pi Re. That is going to be the length that is going to be in contact with the water. So that will be my force. Now they are saying that this force is balanced by a weight of 3.97 grams. That means I can say that this force is balanced by a weight of 3.97 grams. 3.97 into 10 raised to minus 3 into G, 9.8. Force we just found out is T into 2 pi Ri plus 2 pi Re is 3.97 into 10 raised to minus 3 into 9.8. What I asked you to find out tension, you should be able to get that. T is equal to 3.97 into 10 raised to minus 3 into 9.8 upon 2 pi Ri plus 2 pi Re. Substitute the values and you should get the answer. The answer to this sum should be 0.072 newtons per meter. Right? This finishes this chapter. We'll stop this here for the day. Thank you very much.